Hey everybody. So in the last couple of videos, we started looking at sine and cosine graphs. In this one, I want to do an example of, so if we're given a function, a sinusoidal function, like the one that I have up here, how do we graph that function? And there are different approaches to this, and I'm going to go through the one that I like the best. You're welcome to find other resources, and if any way that gets you the right answer is fine, as long as you can do it consistently. But here's the way that I like to do it. So we remember from the previous videos that we have all these constants in our sinusoidal function. In our sinusoidal functions, and they each mean something different in terms of graphing. And so I'm just going to go through the order of how I do things to graph. What I do is I'm going to look at A, D, and B first, and I save C for last. And I'll talk about why when we get there. It might make some more sense when we get there. So first, I'm going to just collect some information, right, about A, B, and D. So A, remember, tells me the amplitude, or at least the absolute value of A is our amplitude. In this case, that's just going to be 3, right? Absolute value of -3. And then I'm just going to make a note, the negative flips graph over the x-axis. Okay, so that's from transformations. That 3 out in the front, if we started with our regular cosine graph, this would flip it vertically. Okay, so that's what our A does. D gives us the midline. So the midline is y equals D. In this case, D is 2. Okay, and while I'm doing this, I'm going to start making a quick sketch. Yeah, let's make a quick sketch, and then we'll go to the graph with a little more detail of kind of what's happening so far, right? If I start with cosine, there's a period of 2 pi. Cosine usually starts here. It goes down and then back up over the course of its period, right? Well, the first thing we did was flip this thing. So we'll be getting something like this. And then we're raising it up 2 units. So now the midline is somewhere all the way up here. So far, it's going to look something like this. I'm not being very detailed at all. I'm just getting it in my head what's happening to this thing so far. I flipped it over and raised it 2 units up. And then we've also stretched it from an amplitude of 1 to 3. I'll use a different color now. So remember, the amplitude is our distance from the midline, our maximum distance. So we see here, this is a distance of 1, or right here, this is a distance of 1. When I stretch it now, the graph is going to go quite a bit higher and lower. Whoops. Right. Again, this is my sketch. This is not even close to something that I'm turning in. I'm just like thinking through the process as I get there. And I'll mention one other thing that I'm doing, but I want to say it very explicitly. I'm drawing just one period, because once I have one period, it's easy to repeat it to get the entire graph. So I just need to focus on one period. Right now, I'm looking at 0 to 2 pi. Okay. Let's get one more piece of information and then move to this nicer graph. And that's going to be, what is the period? Remember, the period is related to the B value, and we have the formula, period. I usually call it P, is 2 pi over B. So in this case, that's 2 pi over 2 equal to pi. So my new period is going to be pi. So I'm not going to try to, this drawing is already past the point of being useful, but it's going to squish the whole thing. So I'm going to come over to this graph paper here and sketch what we have so far. So first, I'm going to put in, let me make this a little thicker. Let's try this. Maybe this is too thick, but I'll do it for now. Here's our midline, okay, at y equal to 2, okay? And according to the amplitude, to A, our amplitude is 3, meaning the furthest away we're going to get for this function is down to -1, and the highest we're going to get is 5. I'm just putting those two in to keep my graph's going to go along this band between -1 and 5 in the y values, okay? And my period is pi, so from 0 to pi, I should go through a complete cycle. Remember, I'm doing the phase shift afterwards. That's the C value. I like to save that until the end, but I just want to get a picture of this thing before I shift it, okay? So here's what I like to do. If we have a period of cosine, whoops, that's not what I wanted to do. Hold on one second. There we go. If we have a period of cosine, let me get a new page over here. So I'm just going to draw the x-axis, 0 to 2 pi. If I graph this, it starts +1, ends at +1. At pi in the middle, it's down at -1, and then there are zeros halfway between. So it's going to look something like this. Notice that there are kind of 5 significant points. There's the beginning of the period, which is at a maximum. There's a quarter of the way through, which is at the midline. Halfway through, we're at a minimum. 3/4 of the way through the period, we're at the midline, and then at the end of the period, we're back to the maximum, okay? I like to think about these 5 points. So on this graph here, that's the beginning of the period. The end of the period is now pi, right? So normally a period is 2 pi, but the same pattern is going to happen, just squished up. The other 3 points are there's halfway between, the halfway through the period, and then there's, we'll make another mark at a quarter of the way through and 3/4 of the way through. I want to figure out where my graph is at each of these points, and that will give me a basic picture of what's happening, okay? So let's go ahead and do this. So I'll do the graph in red. At the beginning of the period, let's go back up to our information. At the beginning of the period, where should my graph be? Well, normally at the beginning of the period, sine is at its maximum, but we flipped it and stretched it. And so it's at its minimum, right? We flipped it over and we also stretched it. So at the beginning of this whole thing, cosine is now at a minimum, right? Again, I'm thinking about, well, what we did in this quick sketch here. Cosine starts usually at a maximum, but because we flipped it and once we raised it, we flip it and then stretch it, the flipping puts us at a minimum, and the minimum tells me the amplitude tells me that minimum is 3 below. A quarter, 3 below the midline, which in this case is 2 minus 3 and -1. A quarter of the way through the period, no matter the fact that we flipped it, doesn't matter. Those zeros are still there, or the midline values are still there. We're at the midline again. Halfway through the period, we'll now be at the maximum. 3/4 of the way through the period, we'll be at the midline. And by the end of the period, we're back to where we started. And so now I get a rough sketch of one period of my graph. Right? And I'm just sketching it in because we still haven't done the phase shift, okay? But this is a reasonable picture so far of what this thing is going to look like. Let's just put in a couple of points. One thing that's nice to do, and this is a good moment maybe to take a moment to explain why we would even graph these by hand. Obviously, we have computers, we have calculators, we have phones, and we can graph easily on our own. I find the exercise of going through these graphs to be really, really useful in understanding what these numbers tell us, right? We want to build intuition about these numbers, and this is one of the best ways. We're gonna do both directions in other videos. Right now, we're taking a function and getting the graph. We want to be able to take a graph and get the function, and that's not going to come easy, and you're not going to develop intuition around these if you don't spend some time building them by hand. So that's my purpose here. I forget the next words I was going to say. So in any event, here's our rough sketch. We still have to do the phase shift. So let's go ahead and, oh yeah, I was going to say, our graphs are not going to be perfect, right? I'm sketching this by hand. This is not a perfectly shaped cosine graph. You can see all the shaky parts to it. And so if I was presenting this to somebody else, showing it to somebody else, one thing I might do is label a couple of points so it's clear what I'm trying to do, right? So for instance, I might label this point as 0, -1, this point as pi, -1. So no matter how bad my picture is, anybody looking at this knows now that a period is pi, because they can see that I'm going through the whole cycle here. And then I would also put in this maximum point. So this one is at pi over 2, and we're up to a value of 3. Okay, so this is some reasonable information to give a person. I might even add the points where it hits the midline, but it's not there yet because we're still got to add some stuff. Okay, so now let's come back to our information gathering phase and add the phase shift. We've done everything we need to so far except for the phase shift. The phase shift tells us how much it shifts left or right. And the phase shift is going to be C over B. In this case, C is pi over 3 divided by B, which is 2. So this is pi over 6, which means it's positive. We're going to move every point pi over 6 to the right. So pi over 6, just ballparking it. Let's do our final graph in maybe this bright blue. So for instance, this point here, about here, is at pi over 4. Pi over 6 is just a little bit less than that. So let's just call it about right here. I'm just eyeballing it. And each point just needs to move over that same amount. So this distance to the right, 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 this distance to the right. And so our graph, in a very rough sense, whoops. And then of course, it continues on. All right, so these cycles will continue. And so the last step I'm going to do is put in points, label these points, right? So this point here has moved pi over 6 to the right. Of course, the y value won't change, but pi over 2, 3/6 pi plus 1/6 pi is 4/6 pi, or 2 pi over 3. And let's put in this point down here. Let me erase this pi over 4. It's inconveniently located. So this one will be at, well, 0 plus pi over 6 is pi over 6, -1. And those are really enough. I could put one more in over here. This one would be pi plus pi over 6. That's going to be 7 pi over 6, also at -1. We can figure out where these intersect, right? So this was pi over 4 plus pi over 6. So 12ths would be our convenient 3/12 plus 2/12 is 5/12 pi. And we're at the value 2. So you can label a couple of points so that even if your drawing's a little sloppy, it's clear what your intention is. And this should be our shifted graph, right? So you can imagine we've stretched it, we've flipped it, we've compressed it, and shifted it to the right. And this is the way I like to do it, these 5 points. So I think in terms of periods, every period is going to go through right? It's either gonna, if it's sine, it's gonna start at 0 and either be going up and then back down. If it's flipped, it's gonna be going down and then back up. Cosine's either gonna start at its max, go down and all the way back up. If it's been flipped, it's gonna start at its minimum, go all the way up and then back down. And I just do the 5 points, right? Splitting up the period, because the period might have shifted, but we're, you know, if the period is 1,000, I can still cut it up into those 5 points. Halfway through is 500. Then you got quarters at 250 and 750, right? Or if your period is some tiny number, you can split it up the same way, and then deal with the shift afterwards. I like to deal with the shift afterwards because sometimes it's inconvenient, like pi over 6 is give me some you know, less intuitive fractions to work with. Okay, last thing, let's just compare this to the computer generated graph. So I have this ready to go here. So I'll erase some of this. Let's just compare it to our bright blue. The dark blue is the real one. And you can see more or less we got it right. My drawing's not perfect, but we're in the correct spots. If I click on, let's erase some of these annotations. So we had this point as 2/3 pi. Oh, I wrote 3 actually. That should have been a 5. So there is a mistake there. We had the right value here. I just misread that blue line under my smudge as a 3 instead of a 5, pardon me. So that should be, that one should also have been a 5. Yeah, I just misread that as a 3 for some reason. In any event, there's our correct point, and notice the computer gives that maximum is exactly the same point. Let's clear all the drawings now and see that nice picture, and maybe compare it to the graph of cosine. So there's the typical graph of cosine. We see it's flipped, shifted, stretched, and shifted vertically. We'll just zoom out to see how they compare. And that's it. And if you're, especially when you're new doing these, if this is one of your first times dealing with these kinds of things, a very simple thing to do is plug in a point. So for instance, I might look at, let's put in the point. For instance, we said, what was our max point here? 2/3 pi. So let's look at a graph of, or let's evaluate f at 2/3 pi. So we have -3 cosine of 2 times 2/3 pi minus pi over 6. What is this going to be? We get 4/3 pi minus pi over 6. Oh, I forgot my plus 2. We'll get -3 cosine. So this is 8/6 pi minus pi over 6 plus 2. So -3 cosine. So 7/6 pi plus 2. If you look at a unit circle, 7/6 pi, cosine of that is going to be negative, something's off. What did I do? Oh, this is supposed to be a pi over 3. Sorry about that. Pi over 3, pi over 3. I just miscopied my original function. So that makes this 4/3 pi minus pi over 3 just gives us pi. Cosine of pi is -1 plus 2. -3 times -1 is 3 plus 2 is 5. Pardon for the collection of errors in this video. But I hope you can follow my mistakes. Our original function, right, just had a pi over 3 in there. I copied it as pi over 6. I had it factored in factored form in the computer, which is where I copied it from. Okay, but what that does confirm for us is that at an input of 2 pi over 3, we get an output of 5. And so this is usually a good way to check your graphs. You can plug in a couple of the points you get to confirm that you've got things in the correct place. Okay, that will do it for this one. Thanks, everybody. I will see you next time.